This is the truth about a so-called Japanese fuel method that supposedly keeps your injectors clean forever, and I'm going to be honest with you right from the start. When I went looking for this viral claim, I couldn't actually find it anywhere. I searched automotive forums, YouTube, TikTok, and enthusiast communities, and what I discovered is that this Japanese secret is either brand new, completely made up, or more likely a mashup of several real practices that got telephone gamed into something that doesn't exist. Here's what makes this worth your time, though. Buried underneath the myth, there are actual Japanese automotive practices that genuinely work, and there's hard science to prove it. None of them keep your injectors clean forever because nothing does, but some of them come remarkably close, and they cost almost nothing. Today we're doing something different. Instead of debunking a myth and leaving you empty-handed, we're going to rebuild it from the ground up using only what the research actually supports. What keeps fuel injectors clean, what's snake oil, and what's the cheapest routine that works? No fluff, no filler, just answers. Something genuinely surprised me during this research, and it's going to surprise you too. If you assume Japan has some superior fuel standard with special cleaning additives, they don't. Japan's fuel standard is called JISK 2202, and it focuses almost entirely on physical properties like sulfur content capped at 10 parts per million, benzene limited to 1%, octane ratings, and ethanol limits. Deposit control additives? Not required. Japan has zero mandatory detergent in their gasoline. What Japan does have is enforcement that would make the EPA blush. Retail gas stations test their fuel every 10 days, and the Ministry of Economy, Trade, and Industry pulls samples from over 45,000 stations every year. Violate the standards and you're looking at criminal penalties including up to 12 months in prison. The fuel reaching Japanese consumers matches specifications exactly. But those specifications don't include anything to clean your injectors. Not one additive. This is where it gets interesting. The United States, the country everyone loves to criticize for lax standards, has actually required deposit control additives in all gasoline since 1996. Every gallon of gas sold in America has some level of detergent in it by law. Automakers thought the EPA minimum wasn't cutting it though, and that's when BMW, General Motors, Honda, and Toyota joined forces in 2004 to create something called the top-tier standard. This demands 2 to 3 times higher detergent concentrations than the EPA minimum while banning metallic additives that cheaper fuels use. The intake valve deposit limit tells you everything. 50 milligrams per valve for top tier versus 100 milligrams for basic EPA compliance. Stack these standards against each other, and something unexpected emerges. Japan requires zero detergent. The US EPA requires some. Top tier requires roughly double to triple what the EPA mandates. The Japanese fuel secret isn't Japanese at all. The best fuel standard for preventing deposits is American, available at about 1/3 of all US gas stations, including Costco, Shell, Chevron, Exxon, Mobil, BP, and Quick Trip. Let that satisfying irony settle in for a moment before we move on. Top tier sounds like marketing, and I thought the same thing until I found the AAA study from 2016 that changed how I think about fuel entirely. This became the definitive research on fuel quality using standardized ASTM testing on a Ford 2.3-liter engine that simulated 4,000 miles of driving. Half the tests used top-tier gasoline, half used non-top tier from various stations, and the gap between them was so wide I had to double-check the numbers. Non-top tier fuel produced an average of 660.6 milligrams of deposits per intake valve. Top tier produced just 34.1 milligrams, 19 times more deposits without top tier. That's a 95% reduction just by choosing a different gas station. The part that really got me was this. Switching to top tier can actually scrub away existing deposits, with 45 to 72% of buildup cleaning out over about 5,000 miles just from changing what you pump into the tank. The cost difference that delivers these results is 3 cents per gallon. Run the math on 12,000 miles a year at 25 miles per gallon, and you're buying 480 gallons, which means top tier costs you $14 to $15 extra annually. $15 buys you 19 times less deposit buildup, partial reversal of existing damage, and 2 to 4% better fuel economy that the study also documented. This is the closest thing to a secret method that actually exists. Not Japanese, not complicated, just picking a different pump. What happens when top tier isn't available near you, or when your engine already has significant buildup? This is where fuel additives enter the picture, and where most people get fleeced. The majority of fuel additives are garbage designed to separate you from your money. One exception exists, though, and it's called PEA, which stands for polyethyramine. Chevron patented PEA back in 1981 and released it as Techron, but the patent expired years ago, which means multiple companies now make PEA-based cleaners. Temperature stability is what separates PEA from the pretenders. Older additives like PIBA break down before reaching combustion chambers where the heat lives. PEA stays stable up to around 1,200 degrees Fahrenheit, which matters because deposits form in the hottest parts of your engine. A cleaner that falls apart before arrival is just expensive gas station candy. SAE technical papers documented PEA achieving 70% flow recovery on dirty fuel injectors, and Southwest Research Institute testing pushed that number to 94% of injector flow restored when used correctly. Products with verified high PEA concentrations based on their safety data sheets include Redline SI1 packing 30 to 50% PEA, Gumout Regain Complete at 30 to 40%, and Chevron Techron. Japanese brands like Waco's Fuel One use what they describe as highest purity PEA, which brings us back to Japan in an unexpected way. The standard recommendation is 1 bottle per tank every 3,000 to 5,000 miles if you're not consistently running top-tier fuel. What nobody mentions in their marketing is that PEA cannot clean what fuel doesn't touch, and this limitation defines whether additives can help your specific engine. Traditional port injection engines spray fuel onto the back of intake valves before entering the combustion chamber, which means detergents actually contact those valve surfaces and scrub them clean with every tank. Direct injection flips this completely, because fuel shoots straight into the combustion chamber and bypasses the intake valves entirely. Those valve backs accumulate oil blowby and combustion residue layer by layer, and every drop of PEA in your fuel tank misses them completely. This fundamental difference is why GDI engines develop carbon problems that no fuel additive can solve, no matter what the bottle promises. GDI vehicles may eventually need professional walnut blasting, where crushed walnut shells get blasted against intake valve surfaces to physically strip away carbon. Typical cost runs $150 to $400, and some shops recommend it every 60,000 to 100,000 miles if deposits become problematic. PA genuinely works for everything fuel touches, but intake valves in direct injection engines sit outside that boundary. Keep this GDI limitation in mind because it comes back later in a way that surprises most enthusiasts. How you drive creates more deposit problems than most people realize, and this gets almost zero attention in fuel additive marketing because they can't sell you a driving habit. SAE research mapped out exactly how carbon deposits form, and it comes down to temperature windows that work like a stovetop burner with a narrow sweet spot. Think of deposit formation like cooking residue that only sticks at certain heat levels. Below roughly 375 degrees Fahrenheit, your engine runs too cold for deposits to form, like a pan that hasn't heated up yet. Between roughly 385 and 555 degrees, you enter the danger zone where carbon accumulates fastest, like that perfect temperature where food burns onto the surface. Push above 590 degrees, and deposits stop forming because it's too hot for them to stick. Cross 617 degrees, and something fascinating happens. Existing deposits actually start breaking apart and burning off, like running a self-cleaning oven cycle. Normal intake valve temperatures hover between 338 and 374 degrees, balanced right at the edge of that danger zone where things can go either way. Short trips tip that balance the wrong way, because 5 to 8 mile drives never let your engine fully warm up. Valves stay in the deposit formation range. The engine runs rich with excess fuel. Moisture accumulates in places it shouldn't, and oil never reaches proper viscosity. Everything about short trip driving accelerates carbon buildup, which is why longer highway drives carry legitimate benefit. Sustained full operating temperature pushes you past those deposit-forming conditions through straightforward thermodynamics. Modern cars flip the old advice on its head, though, and this catches a lot of enthusiasts off guard. You've probably heard of the Italian tuneup, the idea that occasional hard driving at high RPMs burns off carbon deposits. For direct injection engines, remember that limitation we talked about earlier? This backfires badly. SAE paper 2016-01-2252 found that higher engine loads actually create more intake valve deposits in GDI engines, not fewer. Fuel still never contacts those valves regardless of how hard you push, but increased combustion byproducts definitely coat them faster. You're feeding the problem, not fixing it. That drive it hard to clean it out wisdom applied to older port injection engines and became obsolete the moment direct injection took over. Let's talk about what definitely doesn't work, because the fraud in this industry runs deeper than most people suspect. The FTC has pursued multiple enforcement actions against fuel additive scams, and the settlement amounts tell you exactly how profitable these lies became before regulators caught up. EnviroTabs, marketed through Greenfoot Global, cost the company $800,000 in 2013 after they falsely promised 7 to 14% fuel economy improvement from their tablets. FuelMax and their magnetic device faced a $4.2 million settlement in 2006, with the FTC putting it bluntly: the product does not save fuel and does not increase gas mileage. Duralube handed over $2 million in 2000 for fabricating EPA testing claims and promising 50% or greater wear reduction. Slick 50 settled for claiming that PTFE, better known as Teflon, bonds to engine parts. It doesn't bond to anything in there, and DuPont, the company that actually makes Teflon, explicitly warns against using it in combustion engines. The EPA has tested over 100 alleged gas-saving devices and found 0 products that significantly improve mileage. Some actively damage engines or spike emissions while they drain your wallet. Debunked miracle methods circulating online include acetone in fuel, which Snopes rates false, and Mythbusters tested with negative fuel economy results, not to mention the rubber gasket and fuel line corrosion it causes. HHO generators, claiming to electrolyze water into hydrogen and oxygen for combustion boosting, violate basic thermodynamics because splitting water consumes exactly as much energy as burning the hydrogen releases, minus efficiency losses. You're paying to go backwards, and multiple people have served prison time for HHO scams, including 1 5-year sentence. Magnetic fuel line devices lack any scientific basis, and EPA testing confirmed 0 effect. EPA registration sounds impressive when companies trumpet it in their marketing, but that registration only confirms a product won't damage emission control systems. Performance testing doesn't happen. Cleaning verification doesn't happen. Marketing claims go completely unchecked. One industry analysis nailed it. According to the EPA, fuel additives just have to be registered, and it doesn't matter if the product contains grape juice. The cost-effective approach becomes obvious once you stack the numbers against each other and stop listening to marketing. Top-tier fuel exclusively costs roughly $15 extra per year and delivers 95% deposit reduction. That's the baseline. If top-tier isn't accessible and you're stuck with regular fuel plus quarterly PA additives, budget roughly $40 annually. Ignoring the problem entirely means professional fuel system cleaning at $150 to $400 when things go wrong, plus the 2 to 4% fuel economy loss, bleeding $57 to $144 per year in wasted gas from the average driver. Complete failure brings injector replacement averaging $763 to $966, and BMW or luxury vehicle owners can watch that number sail past $4,000. The optimal routine for most drivers begins with top-tier fuel used consistently, because that $15 annual investment prevents the vast majority of problems before they start. Without top-tier access, a PE-based cleaner like Techron, Gumout Regain, or Redline SI1 every 3,000 to 5,000 miles fills the gap at $20 to $40 yearly. Avoiding chronic short trips helps more than any additive can, so combining errands into 20-minute or longer drives lets your engine reach full operating temperature regularly. GDI engine owners should consider annual intake valve cleaner spray at $8 to $12 and budget for professional walnut blasting every 60,000 to 100,000 miles if deposits become noticeable. That's the complete routine. No secrets, no mystery Japanese methods, just applied science at the lowest possible cost. The Japanese fuel method that keeps injectors clean forever dissolves under scrutiny into a myth built on misplaced respect. Japan absolutely has excellent automotive practices and enforcement that puts most countries to shame. And Japanese cars earned their reliability reputation honestly. The specific claim of a secret fuel method falls apart though, especially given that Japan doesn't even require detergent additives in their gasoline while America does. Real answers rarely make good clickbait. Use high detergent fuel. Run a PEA-based cleaner occasionally if you're not using top tier. Stop driving exclusively in short bursts. Nothing keeps injectors clean forever because combustion chemistry guarantees some deposit formation no matter what you do. The right approach costs about $15 annually and cuts buildup by 95% while steering you clear of expensive repairs. That's not as exciting as a Japanese secret, but it's backed by actual research. It actually works. And now you know exactly what to do.